On November 27, 2025, something unprecedented happened. The world's space agencies launched a 2-month planetary defense drill, the largest in history. Europe alone deployed billions in emergency funding. The U.S. Space Force fast-tracked programs meant for 2026. Japan unified military and civilian satellites for the first time. The target? 3I/ATLAS, an interstellar object with 14 unexplained behaviors and a trajectory that changed after perihelion. But here's what's chilling. When asked why this massive response, officials stay silent. Let's dive right in. Picture this. It's just after midnight on July 1st, 2025. While most of the world sleeps, an automated telescope in Chile's Atlas survey picks up something moving through space. Fast. Within 3 days, astronomers across every continent are staring at the same calculations, running them again and again, hoping the numbers will change. They don't. The object is traveling at 221,000 kilometers per hour with a trajectory that screams one thing. This didn't come from here. Its eccentricity sits at 6.14. Anything above 1.0 means it's not bound to our sun. This visitor came from another star system entirely. They named it 3I/ATLAS, marking it as only the third confirmed interstellar object humanity has ever detected. But what happened next would make those earlier mysteries look simple. When Hubble got its first clear look on August 20th, the size estimates stopped people cold. The nucleus measured somewhere between 440 meters and 5.6 kilometers across. That's a mountain traveling faster than anything humans have ever built, wrapped in a cloud of gas and dust, spinning every 16 hours as jets of material erupted from its surface. Every major telescope that could track it started watching, and that's when things got strange. What makes a comet a comet? We've studied thousands of them. We know their chemistry, their behavior, their patterns. But 3I/ATLAS seemed determined to break every rule we'd written. Egypt's Kotamaya Observatory measured its dust-to-gas ratio in mid-August. 0.05. Normal comets range from 0.3 to 3.0. This wasn't just low, it was 10 times below anything observed in 20 years. Then Palomar detected pure nickel vapor with no iron. In every comet we've ever studied, these metals appear together. Always. The ratio here was mathematically infinite. Apache Point Observatory found carbon dioxide dominating at a 7.6 to 1 ratio against water. Comets are essentially dirty snowballs, mostly water ice. This one flipped the entire formula backward. But the feature that really made astronomers pause was the anti-tail. When Gemini North in Hawaii first imaged it, some thought it was an optical illusion. Comet tails point away from the sun, pushed by solar radiation. Always, this tail pointed toward the sun and stayed that way for weeks. The European Southern Observatory measured polarization values beyond anything in their databases. The SETI Institute detected velocity fluctuations that physics models couldn't explain. Japan's Kiso Observatory watched jets erupt simultaneously from opposite sides of the nucleus, not in sequence, but at exactly the same time. Then the Lowell Observatory logged an unexplained brightening. The magnitude jumped by half a point in under 6 hours with no visible cause. The Max Planck Institute noticed the rotation changing, spin period dropping from 16.2 to 15.8 hours in just 12 days. California's Lick Observatory documented smaller bodies traveling in such tight formation with the main nucleus that researchers called it coherent within our resolution limits. 14 separate anomalies, each verified by different teams using different instruments. One strange reading is an outlier you can dismiss. 14 is a pattern demanding explanation. October 30th marked perihelion, closest approach to the Sun. Based on every model and precedent, 3I/ATLAS should have whipped around our star and accelerated back into interstellar space on a clean, predictable arc. Physics doesn't improvise, except the trajectory data coming back didn't match predictions. The outbound path showed a measurable adjustment. Instead of racing away, the new course pointed toward Jupiter's Hill sphere, a gravitational zone where the planet can potentially capture passing objects. Translation: 3I/ATLAS might not be leaving. That's when Harvard astrophysicist Avi Loeb published his analysis. His hypothesis challenged everything. What if 3I/ATLAS isn't a single object? What if it's a swarm, multiple compact bodies traveling in formation? If true, it would explain the anti-tail as the visual signature of trailing members. Loeb's model made a testable prediction. The smaller swarm members should lag behind by tens of thousands of kilometers, visible as a faint structure extending sunward. Dr. Karen Meach from the University of Hawaii pushed back. Multiple jets, extreme outgassing, complex dust behavior, all of it could produce what they were seeing without invoking swarms. She argued for more data before abandoning conventional models. Then, on December 3rd, the European Southern Observatory released imaging showing a structure extending roughly 40,000 kilometers ahead of the nucleus. Other observatories confirmed it. Was this Loeb's predicted swarm, or solar wind effects creating a similar appearance? The resolution wasn't sharp enough to distinguish definitively. Both scenarios remained viable, and that ambiguity, that uncertainty about whether we were tracking one object or many, changed everything about how planetary defense networks had to respond. The International Asteroid Warning Network runs exercises periodically, careful scheduled drills planned months or years in advance. When the IAWN issued a global alert on November 25th, people in the field noticed immediately. This wasn't standard procedure. 2 days later, the official drill period opened, scheduled through January 27th, 2026. On paper, this was the 8th IAWN exercise since 2017. Routine coordination. Then people started seeing the budget authorizations. The European Space Agency deployed what internal documents called the full triad: mission control working around the clock, rapid response modeling, and continuous observation networks. The funding came through in under 2 weeks, multi-billion euros for what was publicly described as a drill. The U.S. Space Force had scheduled their next major tracking rehearsal for late 2026. Suddenly, they moved everything up, deployed new high-altitude assets, and issued fast-track procurement for next-generation platforms. You don't compress 18 months into weeks without a compelling reason. Japan did something unprecedented. Their first-ever national asteroid impact exercise, unifying military, civilian, and commercial systems under single command. These organizations don't typically share data, let alone operate together. Even countries with modest space programs, Australia, South Korea, Brazil, joined, each focusing on the same parameters: high-velocity objects with non-gravitational acceleration. Then researchers noticed a new clause in the drill documentation. For the exercise duration, classified military sensor data could be integrated into the global tracking feed. Condition: only for objects on non-standard hyperbolic trajectories. That authorization had never appeared before. Military and civilian space tracking operate in separate worlds. Bridging that gap requires high-level approval and substantial justification. The timeline tells the story. Trajectory shift detected October 30th. Swarm hypothesis emerged. December 3rd, imaging confirmed structures extending tens of thousands of kilometers, and between those dates, the largest coordinated planetary defense operation in human history quietly launched. Space agencies don't deploy billions in emergency funding for theoretical exercises. Procurement timelines don't compress from years to weeks for practice. Military and civilian systems don't unify for drills. The official focus is testing protocols for unpredictable objects. How do you intercept something if you can't model its acceleration? How do you track multiple targets when systems assume a single object? These aren't abstract questions if you're genuinely uncertain whether 3I/ATLAS is one body or many. The ESA's sensor expansion means they need more eyes and faster processing. The Space Force timeline means whatever they're deploying, they need it operational now. Japan's command unification means they're treating this as requiring resources beyond civilian agencies alone. And that classified sensor clause? Whatever military systems are detecting, the data is relevant enough that transparency protocols get suspended. None of this proves the object is anything beyond an unusual comet, but the response reveals how seriously the uncertainty itself is being treated behind closed doors. Right now, 3I/ATLAS sits 270 million kilometers from Earth. On December 19th, it makes its closest approach. Every major observatory has cleared schedules. Hubble and James Webb will be watching. Ground networks spanning Chile to Hawaii to South Africa are coordinated. Amateur groups worldwide have organized campaigns. The data will be comprehensive. Spectroscopy, dust analysis, jet mapping, trajectory refinement. If the swarm hypothesis is correct, December 19th should confirm it. If conventional models explain everything, the data should fit. Either way, the speculation ends when measurements come in. But there's tension worth noting. The same agencies calling for full transparency, raw data, real-time publication, open peer review, just deployed classified sensors and fast-tracked platforms under procurement blackouts. The scientific community will get data. The question is how complete that data set will be and how quickly the full picture becomes public. The numbers will tell us what 3I/ATLAS actually is. Whether we see all those numbers unfiltered depends on decisions being made right now in rooms we can't access. What's your read on this? Are we watching legitimate scientific caution, or is there more to the response than what's being said publicly? Let me know in the comments below. Here's the bottom line. The largest planetary defense drill in history wasn't triggered by a confirmed threat. It was triggered by uncertainty. 14 unexplained behaviors, a trajectory that changed, billions deployed in 2 weeks, military and civilian systems unified for the first time. That's not how you respond to a normal comet. December 19th will give us answers. The data will show whether 3I/ATLAS is a single object or a swarm, whether the anomalies fit known physics or demand new explanations. But regardless of what the measurements reveal, we've already witnessed something historic. The moment planetary defense stopped being theoretical and became operational in real time. The infrastructure being built right now. The sensors, the command structures, the rapid response protocols. That's the new reality. And if this is the response to one ambiguous object, it raises a critical question. What are they preparing for next? If you want to stay ahead of the official narrative, hit that like button right now and subscribe to Galactic Breaking News. Turn on notifications so you don't miss our December 19th analysis when the data drops. Drop your take in the comments. What do you think is really happening here? And check out our next video where we break down the technology being deployed behind the scenes. This story isn't over. It's just beginning.